Welcome. Today's lesson is SpringBoard Algebra 1, Unit 4, Lesson 28-4, Adding and Subtracting Rational Expressions. Learning targets. Identify the least common multiple of algebraic expressions. Add and subtract rational expressions. To add or subtract rational expressions with the same denominators, add or subtract the numerators, then simplify if possible. So it's pretty straightforward as far as this goes. Ultimately, what you have to remember is that it's just adding fractions just like we learned before. So as an example, 2/3, and we had to add that to 5/3. Then that's of course going to give us something thirds. Well, that something is going to be the top added together. So that's going to be 7/3. So that's essentially what we're doing here. So we already have the same denominator. All right, so in the example that we're given, we have 10 over x minus 5 over x. We look at our denominators. Our denominators are both x, so they're both the same. So since we have a common denominator, our answer is going to be the same denominator. And we simply go ahead and combine the numerators. So in this case, it is 10 minus 5. And so that's going to be 5. And our answer, of course, is 5 over x. All right, example B. This is a little bit of a different one. Instead of the common denominator being just a monomial, we have it what's just a little bit different. So in this case, we have 2x over x plus 1 plus 2 over x plus 1. And though we don't have them, we can kind of imagine these having parentheses around them. And so if we do it that way, it's easier to say, yeah, these are exactly the same. It's the binomial x plus 1 is in the denominator for the first term, and the binomial x plus 1 is the denominator in the second term. And then what we need to do then, of course, is we keep that denominator, x plus 1, and then we simply combine the top. Now, 2x plus 2, we can't combine those because they're not like terms, but the last step, of course, is to simplify. So in the process of simplifying, we look at the top and we look at the bottom, and we simplify them separately. So 2x plus 2 has a greatest common factor of 2. It's going to leave us with x plus 1 because its greatest common factor is 2. 2x divided by 2 is x. 2 divided by 2 is 1. And that's all going to be over x plus 1. And again, we could pretend there's parentheses around here because that visually makes it look a little better. And then when we get done, we want to further simplify. We can, of course, cancel these two out. And we're going to end up with just, of course, 2 as being our answer. Let's do a couple of try these here. Try these A, B. So we're going to add or subtract, simplify the answer. So first one is the A, and that's 3. That's 3 over x squared minus x over x squared. We already have a common denominator, so it's going to be x squared. And then we're going to just simply do whatever the top is asking us to do, and that's 3 minus x. So that's 3 minus x. And at this point here, I can't simplify it any further. All right, so the next one just has more than one term being combined together. So it's going to be 2 over x plus 3 minus 6 over x plus 3 plus x over x plus 3. And we're going to go ahead and combine these like terms. And it's a fancy way of adding or subtracting. And we're going to notice we have the same common denominator of x plus 3. And then on the top, we're just going to go ahead and simplify. Now, we could write that as 2 minus 6 plus x and do the work. We'll work from left to right. What is 2 minus 6? Well, that's, of course, -4. And then plus x. There are no other x terms to combine it with. And so we have x plus 3. And we could rewrite this. We could flip these around and write that as x minus 4 over x plus 3. And then the last example, we have x over x squared minus x plus 4x over x squared minus x. Now what you'll notice here is we could simplify each one of these first, but I'm going to go ahead and recommend that we do our simplifying at the end in this case. So we go ahead and do that. We notice that we have our common denominator of x squared minus x, and then on the top we're just going to add them together. That is x plus 4x, and then we go ahead and try to simplify it. So we'll do the top first. The greatest common factor on the top is x, and when we pull that out, we have x divided by x, which is 1, and then 4x divided by x, which is 4. Okay, of course that will continue to simplify a little more to be well, 5 times x. 5 times x. Okay. Of course, we find ourselves doing this, but you could have actually looked at this and said, hey, that's 1x plus 4x, that's equal 5x. Okay. All right, so the next one, we're going to go ahead and do the same thing. We're going to factor out the greatest common factor. So we see the x, and then x squared divided by x is x, minus x divided by x, which is 1. So we can do that. So I'm going to go ahead and do that. I'm going to put x times x minus 1. Now at this point, we're going to go ahead and simplify. Now 5 doesn't have anything down here to simplify with. So therefore, we're going to go ahead and simplify the x's out, cancel those out. And so we end up with just a 5 on the top and then x minus 1 on the bottom. To add or subtract rational expressions with unlike denominators, first identify the common denominator. The least common multiple of the denominators is used for the common denominator. One way to determine the least common multiple is to factor each expression. The least common multiple is the product of each factor common to the expression, as well as any non-common factors. So this one, it really becomes a lot easier when I show you. Essentially, if we have any common factors, we'll write those down once. If we have any non-common factors, we'll write each one of those down. And then since they're factors, we're multiplying those together. We're multiplying those together to get our least common multiple. So let's just do an example that's showing us the least common multiple. We won't worry about the adding or subtracting just yet. Let's just try to figure out. We have these two factors is what we're going to call them. They're binomial factors in this case, and we're going to go ahead and we're going to try to figure out what is the least common multiple. What is a multiple of both of those? Now, of course, it was easy in numbers. If I had like 10 and 25, for example, I would just skip count by tens and get 50, and 25s and get 50, and 50 was the lowest common multiple, or the least common multiple. Not so clear on the polynomials. So let's just go ahead and look at them. So what we want to do is we want to factor each one of these. So we're going to do x squared minus 4, and that's a difference of squares. It's a difference of squares, so that's going to end up being x plus 2, x minus 2. So that's factored down, the first one. Now the second one, we have 2x plus 4. And when we factor that, we can say, well, I can factor out a 2. And that's going to leave me with, well, 2x divided by 2 is just x. And then 4 divided by 2 is, of course, 2. So now I have the factors of each of the two polynomials we started off with. Then what I do is I look and I say, well, what do these factors have in common? What do these factors have in common? So I look at this and I say, well, okay, they both have this x plus 2. They both have this x plus 2. I don't know, kind of went out on me there for a minute. And so what I'm going to do, knowing that they both have that x plus 2, is I'm going to go ahead and write x plus 2 down. Okay? And I'm only going to write it down once. Even though each one has 1, I'm going to write it down once. And then I'm going to write down everything that's left over. So we have a 2 left over, and we have an x minus 2 left over. So this right here, that's going to be our least common multiple, our lowest common multiple. All right, so the next one we're going to try is determine the least common multiple of x squared minus 2x minus 15 plus 3x plus 9. And so I'm going to do the same kind of thing here. I'm going to factor each of the two polynomials. So the first one is going to be x squared minus 2x minus 15. All right, and the other one is going to be 3x plus 9. So I'll factor each of them independently. And this one I look at it, it's a trinomial. It's not a special product because 15 is not a perfect square. So it is not a perfect square trinomial. So I go ahead and factor it in the usual way. So I know that it both starts off with an x because x times x is x squared. And I look at this sign right here, the second sign, it's minus. So that tells me the signs are different. One's going to be a plus. The other one's going to be a minus. It also tells me I'm going to subtract the factors of 15 to get 2. Subtract the factors of 15 to get 2. And that the larger of the two factors is going to be my minus. So the factors that I can subtract to get 2 of 15 are 5 and 3. 5 and 3. And because I want it to be a negative, the 5 has to be the negative and the 3 has to be a positive. So of course we can always check this by foiling it back. X times x is x squared. X times negative 5 is negative 5x. 3 times x is 3x. So negative 5x combined with 3x is negative 2x. And then positive 3 times negative 5 is negative 15. So we can double check that. Looking at the second polynomial, the greatest common factor of this course is 3. So I'm going to factor out the 3. 3x divided by 3 is x, and then 9 divided by 3 is 3. So that's what I'm going to end up with. Now the next thing I do, of course, I look for things that are in common. Things that are in common. So I'm going to do it this way. I have that 3x plus 3 on both of them. X plus 3 on both of them. So I'm going to just write that down once. X plus 3. And then I write the other two factors down. So it's going to be x minus 5, and that's going to be, to knock that one out, so that's going to be the 3. Let me put that over there. And so the answer is going to be 3 times x plus 3 times x minus 5. Okay, that would be the least common multiple. Now add or subtract rational expressions with different denominators. First, determine the least common multiple of the denominators. Next, write each fraction with the least common multiple as the denominator. Then add or subtract. Simplify if possible. 2 over x minus 3 over x squared minus 2x. And if you look at this, the x can't be factored anymore, but the x squared minus 2x can. So we're going to do that first. So we're going to do it with 2 over x minus 3 over, and I'm just kind of leave them together here so we won't get them lost. So I'm going to factor out the x. Then x squared divided by x is just x. And then negative 2x divided by x is negative 2. Now I still have them in the fraction because I think it works better this way. So now we have to look at this and say, okay, well, what do they both have in common? They have an x, and then write the other one down, which means basically we can see it looking at the two different denominators and say, okay, what is the other one missing to make them look the same? Okay, so you can think of it like that. And what that means is this 2x, in order for it to look like this other one that already has the x, I just need to put in an x minus 2. Of course, I can't just arbitrarily put in an x minus 2. What I have to do in order to be able to accomplish that, in order to be able to make this look like the other one, is I have to go ahead and put it in as x minus 2 on both the top and the bottom. Remember, that equals 1. Multiplying anything by 1 does not change its value. Minus 3 times x times x minus 2. Of course, now as we do the work, we know our answer is going to be x times x minus 2. We know that that's going to be the answer. But now we got to think about, well, how can we do this? Well, in order to combine like terms, so this, we can think of this as being a problem we might have done in the past, where it was 2 times x minus 2 minus 3. In this case, what we would have done, of course, is the distributive property first. So we would have done 2x minus 4, and then minus 3. And we would have gotten 2x minus 7. So 2x minus 7. That's what we've got there. And so that ends up being our answer, is 2x minus 7 over x times x minus 2. Example E. We're going to add negative 4 over 5 minus p plus 3 over p minus 5. And so what we're going to do is we're going to look at this and try to simplify this. And the first thing I want to do is I want to get them to be in the same format, in standard form. So I'm going to rewrite this first term as negative 4 over negative p plus 5. Okay, all I did is switch those around. Plus 3 over p minus 5. And then I want to go ahead and factor out a negative 1 on this denominator down here. This is all part of the factoring we've done before. So I'm going to factor out a negative 1. So it's going to be negative 1 times p minus 5 over negative 4. Sorry, I was wrong on that. That's negative 1 times p minus 5 over negative 4. All right, and that's 3 over p minus 5. And I'm going to put it in parentheses so it looks the same. But then we notice here we can go ahead and do this to get this out of the way. That's going to, of course, cancel out my negative. So it's going to be a positive 4 over p minus 5 plus 3 over p minus 5. And then that, of course, is going to be p minus 5 is in the denominator. And 4 plus 3 is 7. So it's going to be 7 times p minus 5. Now, recall we did a lesson earlier in this activity talking about how to put these in standard form. And that's kind of what we did here by factoring out the negative 1. And then we were able to notice we have a negative over negative, which made it positive. Okay, so let's do the try these DE. Try these DE. And we'll start off with this first one here, where it kind of, in the example here, it breaks it on down. I'm just going to show you how you might want to do it on a sheet of paper, where you're kind of keeping it together. So we'll go ahead and write it out. So it's going to be 1 over x squared minus 1 plus 2 over x plus 1. And then we're going to go ahead, of course, is factor really everything, but we're going to factor the denominators especially. Okay, so we have 1 over, and then x minus 1 is a difference of squares. So that's going to be x plus 1, x minus 1, plus 2 over x plus 1. That cannot be simplified any further. Again, I like to sometimes put it in parentheses so it kind of looks the same. The idea here to make these, now that we have the factors here, to make these the greatest common factor, the way I like to look at it is, okay, this has got an x plus 1 and an x minus 1. This only has an x plus 1. We need, in order to make them look the same, we need an x minus 1. That way now they look the same. And of course, I can't arbitrarily just put an x minus 1 there. I have to do x minus 1 up here to make it, of course, worth 1. And so now what I can do is I now know my greatest common factor is going to be x plus 1, x minus 1. Okay, And then I'm just going to add everything across the top. So it's going to be 1 plus 2 times x minus 1. And then, of course, using the distributive property and everything, we'll go ahead and write it out. It's going to be x plus 1, x minus 1. And that's going to be 1 plus 2x minus 2, because 2 times x is 2x. 2 times negative 2 is 1. And then we're going to go ahead and write it out as 2x. And then 1 combined with the negative 2 is negative 1. And then that's going to be over x plus 1, x minus 1. Okay. And that's how we would leave the answer. B, 3 over x plus 1 minus x over x minus 1. And when we look at this, we have nothing in common. So the only thing we have left over are the two factors that are different. And I like to put them in parentheses. And so basically the greatest common factor is those two things multiplied together. And so in order to do that, we want to make them look the same. And so we'll go ahead and do that by putting the x minus 1 here and the x plus 1 here. So they look the same. They have an x plus 1 and an x minus 1, an x plus 1 and an x minus 1. Of course, we can't just arbitrarily put those down. We have to go ahead and do the same thing on the top. And then x plus 1 on the top over here. Because these are just 1. That's all they are. These are just 1. Okay. All right, so now we're going to go ahead and do this. Our greatest common, our least common multiple then is of course going to be the x plus 1, x minus 1. And then across the top, we're going to have 3 times x minus 1 minus x times x plus 1. And so we go ahead and complete that or simplify that. It's going to be x plus 1, x minus 1. And we're going to go ahead and distribute. So we have 3 times x, which is 3x. 3 times negative 1, which is negative 3. Negative x times x, which is negative x squared. And then negative x times 1, which is negative x. And then we want to go ahead and combine like terms. So we have, first of all, our negative 2, our negative x squared. And then we have a negative x and a positive 3x. So it's going to be plus 2x. And then we're going to have our minus 3. All that over x plus 1, x minus 1. And that could be your answer right there. All right, C. All right, C is going to be 2 over x minus 3 over x squared minus 3x. And so, and this is one of the cases we want to factor them. So we have 2 over x, and there's nothing I can do there, minus 3 over, this is x squared minus 3x. So I can factor out an x, and that's going to leave me with x squared divided by x is x. Negative 3x divided by x is negative 3. Okay, so now I have our denominators factored, and again, we want to make them look the same. So in order to make them look the same, we have to, well, let's see, they both have an x, so we just need an x minus 3 over here. X minus 3. And of course, what I do on the bottom, I do on the top. All right, because that's a 1. All right, so we can go ahead and move along. We have our denominator here of x times x minus 3. Our numerator, we have 2 times x minus 3 minus 3. And then we go ahead and use our distributive property and see what we end up with. So that's 2 times x, which is 2x. 2 times negative 3, which is negative 6, minus 3. And then, of course, we can finish this up down here. That's going to be 2x minus 9 over x times x minus 3. D. I noticed that my example here is not the same as yours, so I'm going to go ahead and write down what you have. So you have 2 over x squared minus 4 plus x over x squared plus 4x plus 4. And so I'm going to go ahead and factor each one. So it's going to be 2 over, well, this is a difference of squares. So it's going to be x plus 2, x minus 2. And then this next one is going to be x over, and this is a perfect square trinomial. So, but I'm going to go ahead and write them out. So it's going to be x plus 2, x plus 2. In other words, x plus 2 squared. And so now what I need to do is I need them to look the same. And so just kind of remember what we need is we need the x plus 2 once, but then we need the x plus 2 and then an x minus 2 and another x plus 2. So for this side to have that, we're going to have to put in another, or put in an x plus 2. And on this one, we have to put in a x minus 2. And if we do that, we will see we have factors x plus 2, another x plus 2, and an x minus 2. Here we have an x plus 2, another x plus 2, and an x minus 2. So we have the same factors in both. So, of course, what we do on the bottom, we have to do on the top. So it's going to be x plus 2 on the top. And here it's going to be x minus 2 on the top. So we'll go ahead and write this out then as our numerator. Our denominator is going to be x plus 2, x plus 2, and then x minus 2. And that's our denominator. And then the numerator, I'm going to go ahead and write it out. So it's 2 times x plus 2 plus x times x minus 2. And so we'll go ahead and use the distributive property. So 2 times x is 2x. And 2 times 2 is 4. X plus x is x squared. Then x minus 2 is x times negative 2 is negative 2x. All that, of course, over x plus 2, x plus 2, x minus 2. So we'll go ahead and combine like terms and put these in order. So it's going to be x squared. The 2x's, the 2x and the negative 2x cancel out. So they have plus 4. All that over x plus 2 squared, x minus 2. Again, all I did is write that down as x plus 2 squared. And that should be your answer right there. Check your understanding. Make use of structures. Sometimes the denominator of one of the fractions, or rational expression, works as a common denominator for all fractions or rational expressions in the set. So in other words, in the example 1/2 and 1/8, the 8 is the least common multiple. In other words, one of the numbers, one of the denominators happens to be your answer. Now, of course, we can see that by 1 over 2 and 1 over 2 times 2 times 2. And we notice that the common one is a 2, and then all the leftovers, 2 plus 2, and that gets back to our 8. So it works out that way. B, write 2 rational expressions in which the denominator of one of the expressions is the common denominator. Okay, so again, just like this one right here, right? 2 fractions. Now here, though, we want to do this with something other than fractions. So it would be something like maybe we had 1 over x plus 1, for example, and then plus, or and, in this case, 1 over, let's just say it's x squared minus 1. And you may look at that and go, well, what are you talking about? Well, it turns out that in this case, 1 over x plus 1, and this one we factor it as 1 over x plus 1, x minus 1. Well, the way to make them look the same is we keep the x plus 1 and we throw in the x minus 1. So it ends up being that they're both this one. They're both going to look like that one there. C. Show how to add 2 rational expressions that you wrote in part B. Well, of course, if we want to go ahead and continue this to add these up, the only thing we added was this x minus 1. Okay, so to keep with the way I was doing that before, I'm going to go ahead and erase that for just a moment and put that in red, because that's the change that I made. Was I put the I keep wanting to erase here. I put the x minus 1 there to make them look the same. Okay, and so in order to add these, we have to just write the common denominator down. So it's going to be x plus 1, x minus 1. And then we'll use the distributive property. So 1 times x is x. 1 times -1 is -1 plus 1. And when we go ahead and add across, it's x minus 1 plus 1 is just x over x plus 1, x minus 1. Again, you can pick your own numbers for B and C that you want, or your own rational expressions, but either way. Item number 2, list the steps you usually use to add or subtract rational expressions with unlike denominators. Well, essentially what it's asking, it's wanting you to do here is to, first of all, find the common denominator by using least common multiple. Then, of course, you would combine or add or subtract the numerators over the least common multiple. And then, of course, the last step is simplified. So just to write these out is, find the least common multiple for the denominator. Okay, and then add, subtract the numerator, and then of course simplify. Okay. I believe that finishes everything for me here. Yeah, the rest is your homework. Feel free to call me, come to tutoring, the Zoom tutoring on Wednesdays at 3 o'clock, or send me an email or what have you. But if you need help, get help. They're also going to make post some videos. Google it, whatever you want to do, or whatever you need to do to get the help. And well, this concludes today's presentation of the SpringBoard lesson 28-4, adding and subtracting rational expressions.